Before I start, I'd really like to thank, I've been very fortunate to work with a great team of people in my office and an even better team of producers, and it's just been a fantastic group to work with, and thank you very much. So, as Joni suggested, that's the title of my talk. The whole backbone of the northern beef industry is grass, and obviously that's totally determined by rainfall. And you can't produce cattle unless you've got grass, and some of my sex-obsessed veterinary friends sometimes forget that. But if you don't have that grass there, there's no animals. When you live in a highly variable environment like we do, and the amount of pasture can fluctuate by a factor of 12 to 20 between years. In fact, the magnitude of that fluctuation is a lot greater than that of the rainfall. It can be very difficult to manage. So it's quite easy to go from a situation like that on the left, where there's a lot of grass in a good season, to being on the edge, maybe the edge of the wet season, and just hanging on for the last moment and hoping it will rain, to ending up in that situation there with those cattle on molasses, absolutely no grass, and then that horror picture which I got off the Weekend Australian. Climate variability obviously isn't anything new in Australia, and a lot of people have been managing it very, very well, and there are recommended strategies to manage for climate variability. They're not strategies that have been thought up in a laboratory. They're strategies that the scientists have copied off the successful producers, people like Tom Mann, Roger Landsberg, and John Lyons. So there are those strategies out there. And if you look around, it's quite intriguing that there are some properties that are managing for climate variability very, very well and have good cover and good animal production, and that you might find a property right next door under exactly the same conditions with the same soil type that's taking a different management approach. So what intrigues me is why don't people apply these recommended strategies? And this is my own personal view. It's not the departmental view. Obviously, it's a complex problem. There are a whole lot of issues involved. For example, the live export debacle 2 years ago has obviously had a major effect on how people in northwest Queensland manage the latest drought. But something that I believe that we as researchers and extension people can really focus on is this constraint, this belief that sustainability and profitability aren't compatible. And a certain element out there think that they can't afford to be sustainable. And it's very difficult to argue this when there's no hard data to show what the profitability or the economic performance is of some of these recommended strategies. In 1997, the Lyons family were generous enough to enter into an agreement with the DPI, and we established the Wambiana grazing trial with the objective of specifically looking at a whole range of stocking strategies to quantify some hard data on how these strategies actually perform. And very importantly, it was also to demonstrate it, because it's that power of a physical demonstration that can really, I believe, convince people to change their management. If we were going to do this work, we had to have some core principles, and the two non-negotiables for me were that it had to be replicated so that we could analyze it statistically. And it had been beaten into me in my short time in Australia that if it wasn't relevant to the industry, you were never going to change anything. So in setting up the trial, we chose 5 grazing strategies, and some of these were applied by industry already. Things such as stocking at long-term carrying capacity, moderate stocking. Then there's just heavy stocking, where the assumption is when you run into a dry season, well, you just feed molasses and urea and you just muddle through. The third strategy involved varying stock numbers annually based on how much feed you had in the paddock, and there the obvious time to make that adjustment was in May. We had a variation of that where we used the Southern Oscillation Index combined with a forage budget to adjust our stock numbers, and that was done in October because that's when the SOI gives you your best signal. And then finally we had a system of rotational wet season spelling, a very simple system based on 3 paddocks, and every year one of those thirds would be locked up for the whole wet season. Based on some of the previous eco-graze work, there was evidence that if you spelled, you could run it at a slightly higher stocking rate, and that's why we ran it at 6 hectares per animal equivalent, as opposed to the 8 hectares for the moderate stocking. When we laid out the trial, this is just very briefly, the main point here is that we replicated all 5 treatments twice, and then we used a bit of a odd paddock design because one of our main objectives was to try and simulate commercial paddocks, and commercial paddocks have a range of different land types in it. So basically our paddocks all have 3 land types that, dominated by the box country. They've also got heavy clays and they've got silverleaf ironbark, and the proportion of those soil types is basically the same in all the paddocks. As I mentioned, relevance to the industry is a key feature, so we've had a grazier advisory committee that have been on board since before the first treatments were established, and we have an annual meeting there where we advise and discuss things like stocking rates or burning or supplementation. And in that photograph there, young Tom Lyons is pointing out to me that I've been misidentifying a grass for the last 20 years. So briefly, some of the measurements. Firstly, we do a lot of measurements on species change and pasture condition across all the different land types. We measure animal production. We've got Brahman cross cattle, and they're managed according to the industry standards for that area. The cattle go to the meatworks, so we get the meatworks feedback sheets and we can work out the economics of the different treatments. We also do work on soil loss and runoff, but I'm not going to discuss that here. We've collaborated with CSIRO and lately James Cook University, looking at how the different grazing treatments affect biodiversity. And with Stephen Bray and other colleagues, we look at woodland structure, carbon storage, both in the soil and above ground. And then we have the pleasure of setting it all on fire at the end and looking how at fire affects the woodland, and that data is presented in a poster outside. So it's a long trial, not as long as Kidman Springs, of course, but so I'd just like to give you a brief history of what happened. Firstly, the rainfall. We had 4 very, very good years of rainfall, and we put a fire in there in the middle just to try and manage the woody component. We then had 6 very bad years of well below average rainfall, and then the last 7 years have been exceptionally good, and we applied another fire in October 2011. And the last year has actually been below average rainfall, but actually pretty good from a cattle point of view. So I'll just show you what's happened with the different treatments. Firstly, looking at the heavy stocking rate, and this graph shows the rainfall there on the right axis in the bars, and on the left is the stocking rate. And just to make it more, to make it clearer, we've put it in animal equivalents per square kilometre. So we started off there at about 23 animal equivalents per square K, and that went along quite happily in those first good seasons. You can see there's no problem there. Then we ran into the droughts, and we started running out of feed a bit, and one of the replicates of the heavy stocking rate had to be destocked for 3 months, and the animals fed hay. And you can see their paddock in the background there. There's literally was not even a leaf on the ground. It was totally bare ground. So obviously the aim wasn't to destroy the paddock completely. We were trying to do what a rational grazier would do. So we cut our stock numbers by about 1/3 in those latter dry seasons. And then with the good seasons, we've been able to go back to the previous heavy stocking rates, because we believe that's what someone whose philosophy of heavy stocking would do. With a moderate stocking rate, which was run at half the rate of the heavy stocking rate, it started off looking good. We went through the dry seasons. We got a bit, the feed was eaten down, but the cattle were in good condition. We never had to feed molasses or urea. And then we hit the good seasons, and there's just been no problem at all. So just briefly in comparison, the moderate stocking rate hasn't changed at all over those 16 years. Then we go to the variable stocking, where we've been adjusting numbers based on how much feed is in the paddock. We started off in those good years with masses of feed, and we accordingly cranked the stocking rates right up. In fact, we went above the heavy stocking rate level at that stage and totally overshot the mark, and it was pretty obvious very soon that we'd been a bit over-optimistic, and those cattle are in fairly poor condition. And as a result, we had to cut the stock numbers very rapidly going into those droughts. We kept them down, but as a result of that, in July 2006, that photograph shows it was still very dry, but those cattle are in very good condition. There's nothing wrong, there's more than enough feed there, and they were actually stocked at that particular point lower than the moderate stocking rate. Then just getting onto the rotational wet season spelling. As I indicated, we ran it initially slightly higher than the moderate stocking rate. We had the big fire across the whole experimental area in 1991, but then we got very clever and we thought, before we lock up a paddock, we'll burn it, and then it will have a whole wet season to recover, and we'll also control the bush. So the first year, that worked really well. The second year, it worked really well, and it rained for the first month, and then it didn't rain, and we ran into the drought. And as a result, that paddock was burnt in November 2000, just after 9/11. We locked it up for 2 full wet seasons and grazed it in the dry season, and this is what it still looked like in October 2003. Now here's where we learnt we were actually applying adaptive management. We could have carried on and not spelled that section of the paddock and carried on according to the treatment and proved that rotational spelling really stuffed your country up. Because the rest of the paddock that wasn't being spelled was being overgrazed. That's where we learned we had to cut our stocking rate back to the moderate stocking rate, and we also had to start applying our spelling like the way some of the producers in our area would apply it, and not apply it rigidly, but apply it to the areas that need to be spelled. So once we'd got over that hiccup, the rotational spell has performed very, very well, and you can see those animals there's heaps of grass and everything's fine. And that graph just briefly shows we've had a range of rainfall years and a range of stocking rates through the different treatments. So getting onto the results. Firstly, if we look at the pasture change, here's one of our monitoring sites on the moderate stocking rate paddock in March 2000. A very good year. You can see it's in very good shape. In the middle of the drought, the cover's a lot reduced, but there's still a good stand of perennial grasses there. And then with the good years coming back, things have recovered a lot. If you compare that with a heavy stocking rate, that was in March 2000. There's a very good stand of desert bluegrass there. A few years later in February 2005, that's exactly the same site. The cover is somewhat reduced, and some of the species are a bit difficult to identify. And then by March 2012, you've seen there's been a lot of apparent recovery. So things look pretty good. And that change, however, it looks like there's been a massive recovery with the arrival of those better seasons, but a lot of that change has actually been superficial. And if you look at some of the background data, and this is looking at the density of 3P grasses, those are the ones we refer to as perennial, palatable and productive grasses. So in 2006, which was after 5 years of below average rainfall, you could see that the density of perennial grasses was 3 times higher under the moderate stocking rate than in the heavy stocking rate. and it was also lower under the variable stocking rate than under the moderate stocking rate. And that difference there arose from the fact that we'd been overstocked before we went into the drought in the variable strategy. If you then go forward 7 years to this year and you compare the perennial grass density here, so the maroon is the 2006 and the blue's this year, you can see there's been recovery across all the treatments and increase in perennial grass density. But the most important factor is, if you look at the heavy stocking rate, it is nowhere near what it is in the moderate stocking rate or in the rotational spell. So despite the superficial improvement in cover, fantastic improvement in cover, a lot of green grass there's still this damage that has occurred to the perennial grass component. And interesting, if you look at the variable strategy, that has been stocked very lightly since early in the drought, and you can see that density of perennial grasses is still lower than in the moderate stocking or the rotational spelling. So two things that are happening here. There hasn't been recovery in the heavy stocking rate, there hasn't been that bounce back, and secondly, the damage that we inflicted about 8 years ago is still showing through in the long term. That feeds directly into the pasture composition, and you can see that the yields in the heavy stocking rate is a lot lower than the moderate stocking rate. So this is after 7 very good years. And then the important bit here, I've got the different species compositions. Those are the 3P grasses. The 2P are palatable or perennial. They just don't get all three. They're not all of the 3Ps. The important point here is just the amount of 3Ps in the heavy stocking rate compared to the better treatments and the difference in yield. So that's a direct impact on animal production. One major change that has occurred in the trial has been the increase in Indian cooch, and that's been quite dramatic in that in the middle of the 2000s there, if we found 1 or 2 plants of Indian cooch across the trial, we'd sort of comment about it at Smoko, but you can see how much it's increased, and particularly in the heavy stocking rate treatment. What's interesting there is it actually seems to have invaded to a certain extent across all treatments. So that's been a major change, and I think that's a major research and extension challenge that we're facing in the Dalrymple Shire. It's just been the explosion of Indian cooch. I'll now get into the animal production. If we look at the individual live weight gain per animal, averaged over the 16 years of the trial, there's a clear difference there with the heaviest individual gain under the moderate stocking rate. That equates to about 19 kilogram difference between the heavy and the moderate stocking rate. And the other treatments, the variable, the spell, and the SOR, quite reasonably similar to the moderate stocking rate. That better individual animal production has also translated through to meatworks premiums in most years, but I add not every year. There's been a premium of about 15 cents per kg for the animals coming off the moderate stocking or the better stocked treatments. That's given heavier carcasses, and obviously it's given a greater total carcass value. Now, another hidden benefit that would be evident on a property would be a faster turnover rate of animals and an earlier age at marketing. So I think those are sort of uncaptured benefits that would occur in real life. If we look then at the total beef production per unit area, so that's just the total amount of live weight gain per hectare, there the story is different. There is a higher total production of the heavy stocking rate than the moderate stocking rate, about 8 kilograms in total, and sort of intermediate levels with those other treatments. But the point is, even though the total beef production was higher under the higher stocking rate, it came at a major cost. So it was quite all right in those good years, but there were 4 years of drought feeding, expensive molasses and urea supplementation, and a lot of bare ground. The key point of interest, of course, is how does it affect profitability? we did an economic analysis with the help of our economist Bill Holmes. So we started off with an assumption that we assumed an interest rate of 7.5% on livestock capital. We included a price premium for condition of between 10 and 20 cents, depending on condition. We didn't automatically apply it to cattle off the lighter stock strategies, and we used actual costs of 2010. So the graph here shows the accumulated gross margin over 16 years of the different treatments. And what it's showing is we've got the rainfall on the right axis, and that accumulated gross margin is just simply the gross margin from year to year, just added up. So in the first 5 years, the heavy stocking rate treatment really made money and was way ahead of the other treatments. But as soon as it hits those bad years, it just started losing money, and it lost money. It had a negative gross margin for 7 consecutive years due to higher costs and price penalties at the meatworks. The variable stocking rate also powered ahead, had a bit of a dip when we had to destock, but then carried on rising, when you can see the moderate stocking rate has just risen consistently over that entire 16 years. The last point to note is that even with those good years and the heavy stocking rate has been doing very well, it still hasn't caught up with those other strategies. So after 16 years, based on our economic analysis, the heavy stocking rate is certainly unprofitable. The big question is, we did that with steers. How does that apply to breeders? I've been very lucky to be able to work with some modelers, Joe Scanlan and Neil McLeod. And GRASP is a biophysical model that basically grows grass under a simulated condition and converts it into live weight gain, and then that feeds into Neil's enterprise model. So we simulated a breeder property near Charters Towers, which was selling bullocks at 590 kgs, and we ran rainfall windows, 30-year rainfall windows. So we got the trial data. We used that to calibrate GRASP specifically for a single soil type on the trial. And then the model was trained to the trial data, and there's very good agreement between the model and the actual trial data, and then it was scaled up to the enterprise level. If we look at the model outputs for the GRASP enterprise model, and this is for a 30-year climate window, it tends to agree with the trial results in that the best economic return was from the moderate stocking rate. So that's the average return on capital invested over the 30 years. What's also interesting, though, is if you run different climate windows, there is a basic agreement that the moderate stocking rates tend to give the best return. But what's interesting is that with a variable climate, the optimum actually varies depending upon the climate window. And that reinforces, I think, to me, the message that you have to manage with the climate. There isn't some single magic stocking rate. So I'll just like to sum up with some key findings. Firstly, our heavy stocking rate treatment performed well initially in those good years. It had economic loss in 5 out of those 16 years, and there was a decline in land condition and carrying capacity. So it's certainly shown to be neither sustainable nor profitable. But I have to say, one interesting point is that there's been no overall decline in animal productivity up to this point. So basically, you couldn't say that the whole system has collapsed or even come close to that. The moderate stocking rate has been obviously profitable and sustainable over all those years, but we have picked up problems with that. Firstly, there was definitely overgrazing in those drought years because we kept the stocking rate fixed. So that indicates that some form of stocking rate flexibility is very important. There's also been patch grazing. So again, that reinforces the need for spelling. The variable strategy was profitable in all of those years except that one particular year when we were overstocked going into the drought. And generally, animal production was good, but there has been a decline in pasture condition. And as I said, that was from that one point when we were overstocked. problems we've identified there is that there's obviously a major risk of causing pasture degradation going from good into bad years, and there's obviously a major economic risk. So changes in stocking rate obviously need to be done fairly gradually and in a very risk-averse manner, and like the moderate stocking rate, I would suggest spelling is also important. So based on that, our recommendations would be that in managing for a variable climate, you should aim for flexible stocking rates based on long-term carrying capacity of the area, that stocking rate changes should be applied in a risk-averse manner with slow increases and rapid cuts if you happen to run into a run of dry seasons, and that regular wet season spelling is a very important part of that. In the second phase of the Wambiana trial, which started just 2 years ago, we've taken some of the learnings from the earlier phase and we've adapted some of our management strategies to incorporate those learnings. So we've continued with the heavy and the moderate stocking rates unchanged. The rotational spell has been changed from a 3 to a 6 paddock system to allow more flexibility in the area that we spell. And then the 2 variables have been renamed flexibles because we're a lot more risk-averse with changes, and we examine stocking rate changes 3 times through the year. I'd like to close off with a big thank you to our main sponsors, Meat and Livestock Australia, various other funding bodies, and particularly the Lions family of Wambiana, who quite literally, we couldn't have found better cooperators. So thank you very much.